All right, let's dive into something truly mind-bending today, the science of exploring alien atmospheres. We're going to be walking through a landmark 2010 paper by Sarah Sager and Drake Deming, and it tells the incredible story of how this field went from, well, basically science fiction to a totally tangible reality. So, let's get into it.
You know, it all really boils down to this one question, doesn't it? It's maybe the biggest question we've ever asked. But what's so wild is that for the first time in human history, we're actually building the tools to try and answer it. And the key, as it turns out, might just be hidden in the air of planets that are hundreds of light years away.
But here's the crazy part. Not that long ago, this whole idea was seen as a total fantasy. This quote just nails the feeling back then. In the mid-1990s, when we were just starting to find planets outside our solar system, the idea of actually studying their air, to most scientists, that was just laughable.
So let's start right there with that impossible dream. A scientific quest that honestly sounded like it was ripped straight from the pages of a sci-fi novel.
Just try to picture it. You've got an exoplanet, this impossibly small speck of dust trillions of miles from here, and it's completely washed out by the blinding light of its own star. Now, trying to detect a whisper-thin layer of gas around that tiny dot, it was like trying to spot a firefly sitting on a giant searchlight from the next state over. It just seemed absolutely undoable.
And yet, it happened. Science fiction became science fact. There was one single pivotal moment that turned this entire field completely on its head.
And the whole thing happened ridiculously fast. In the mid-90s, nobody believed it was possible. By 2002, we had the first real proof. And by 2010, when our source paper was actually written, this was a booming, established field of science. That's a massive, massive leap in less than 2 decades.
So, here it is, the big breakthrough. In 2002, astronomers used the Hubble Space Telescope to watch a planet as it passed in front of its star. And as it did, a tiny sliver of starlight actually filtered through the planet's atmosphere on its way to us. And that light, it carried the chemical signature of that planet's air. Now, it was a faint signal, for sure, and some folks still thought it might be a one-off fluke. But it didn't matter. The door had been kicked wide open. It was possible.
And once that door was open, you better believe a whole generation of astronomers just rushed right on through. The impossible dream suddenly had real data to work with. The momentum was just unreal. What started with one single, incredibly difficult detection in 2002 absolutely exploded. By 2010, we had already peeked into the skies of more than 25 different alien worlds. A whole new field of astronomy wasn't just born, it was growing up fast. So who were the first rock stars of this new show? Well, they were a weird class of planets we call hot Jupiters. Just imagine a huge gas giant, like our Jupiter, but orbiting its star so close that its year lasts only a few days. They're big, they're puffy, and their atmospheres are superheated, which, believe it or not, made them the perfect first targets. They were just easier to see. By studying them, scientists could practice and perfect the super delicate techniques they'd need for the main event, smaller, rocky worlds.
And what were we actually learning? Oh, we weren't just seeing that atmospheres existed, we were starting to actually map them out. We started finding the chemical fingerprints, the spectral features of molecules like sodium and even water vapor. We could measure these insane temperature differences between a planet's permanent, scorching hot day side and its frigid night side. We even started to figure out the vertical structure, how the temperature and pressure changes as you fly up through the clouds. We were literally drawing the first weather maps for worlds light years away.
Now, all of this science, the molecules, the temperatures, it's absolutely incredible stuff. But it was all building towards something much bigger. It was all about trying to answer that one question we started with.
This right here, this is the holy grail. It's called an atmospheric biosignature. And what it is a chemical clue in a planet's air that is so weird, so out of balance, that the best explanation for it is, well, life. A classic example is finding tons of oxygen and methane together. On their own, those two gases would react and destroy each other. So if you find both of them constantly being replenished, something's going on. And that something might just be biology. It's the ultimate prize, finding that chemical echo of life in the light from a distant star. So, finding that echo is the entire game. The techniques were proven on those hot Jupiters, but let's be real, those fiery giants aren't where we expect to find anything living. So the big question for the field became, okay,
We have these amazing new tools, where do we point them next?
And that brings us to the future, or at least the future as they saw it back in 2010. A real roadmap was finally starting to take shape.
The plan had two big steps. The next logical move, the immediate focus, was to go after super-Earths. These are planets that are bigger than Earth, but smaller than Neptune, that are orbiting in the sweet spot, the habitable zone of small, cool stars called M-dwarfs. That was the practical next step. But the ultimate goal, the big dream, that was to build telescopes so powerful they could actually take a direct picture of a planet just like ours, a pale blue dot orbiting a star just like our sun, and then analyze the light from that single pixel.
And that's really where this leaves us. Think about that journey for a second. From a scientific fantasy in the 90s to a clear path forward. The quest to answer, are we alone, is without a doubt one of the greatest scientific adventures of our time. And it makes you wonder, when we finally get that first faint picture of a true Earth twin, what secrets are going to be hiding in its light?